Okay. Alright. What is the instantaneous rate of change at x equals 2 of the function given by blah? So if f of x equals x squared minus 2 over x minus 1, what's the instantaneous rate of change mean? The derivative? So, low d high minus high d low all over low. Plug in what? What's 2 minus 1? Times minus. What's 2 squared? 2 times 1 is 2. All over 1 squared, which is 1. Right? 4 minus 2 is... Whew, not negative 2. 2. Okay. Okay. It says let f be a function given by 3e to the 2x and g be a function given by 6x cubed. At what value of x do the graph of f and g have parallel tangent lines? What does that mean? They have the same slope. So shouldn't that mean we just set the derivatives equal to each other? What's the derivative of 3e to the 2x? Is it product or is it just chain? Okay, so 3e to the 2x times 2. And then what's g prime? I'm going to go with 18x squared. So when does 3e to the 2x equal 18x squared? I'm going to divide by 6 just to make it easier on myself. When e to the 2x equals 3x squared, right? How would you solve this with your calculator? I either graph y1, graph y2, find the intersection, or I would take my 89 and say, hey, 89 solve that equation. Or I would subtract this over, set it equals 0, and graph that and see where it crosses the x-axis. Yeah? Okay, move on. We already did that one, so we're good. Let f be a function given by 2e to the 4x squared. At what value of x is the slope of the line tangent to the graph of f equal to 3? So when, at what value of x is the slope of the line tangent, which is really just the what? Slope of the line tangent? Which is the what? The derivative. For what value of x is the derivative equal to 3? So what is the derivative of 2e to the 4x squared? So 2e to the 4x squared times, there you go, and I want to know when that equals 3, right? Again, y1 minus 3 equals 0, graph on the zeros. Okay, move on. Let f of x equal the square root of x. If the rate of change of f at x equals c is twice its rate of change at x equals 1, then c equals. Okay, let's first find the rate of change of f. What does that mean? Find the what? Okay. So if this is x to the 1/2, what's the derivative? You're thinking antiderivative. Good joke. Right? 1/2 x to the negative 1/2, which is 1 over 2 square roots of x. So what they're saying is, if the rate of change at x equals c is twice its rate of change at x equals 1, then c equals what? Does that make sense? Rate of change at c twice the rate of change at 1. What is the square root of 1? What's 2 divided by 2? 1. So 1 over 2 square roots of c equals 1. I feel like we solved this earlier in the day. Yeah? Multiply by the square root of c on both sides, and then square both sides. 1/4. Okay. Amazing. Whew. Hmm. It's gonna hurt your feelings if we skip both of those, isn't it?
No,
No.
to be honest.
Right quick, just to say this right here. If this is W, this says find W prime. What's that? Just find the derivative and plug in 20. And using your calculator, right? Using correct units, explain the meaning. The derivative. Well, if W is the wind velocity in miles per hour, then what's W prime? Okay. Well, actually, W and... Okay, wait a minute. Wind chill. Okay, wind chill is the temperature a human feels based on the air temperature in degrees and the wind velocity in miles per hour. So wind chill is this, right? So the rate of change of the wind chill in... Oh god, that's so weird. Wind chill is the temperature in degrees Fahrenheit and the wind velocity, but it doesn't say like what it is. I don't like that question. It's true. They definitely didn't ask another one like it. That was that weird. Let's talk about mosquitoes. I hate those. Hopefully not right now. Okay. Alright, for 0 to 31, the rate of change of the number of mosquitoes on tropical island at time t days is modeled by this function. So this is the rate of change, mosquitoes per day, right? There are 1,000 mosquitoes on tropical island at time 0, so that was my initial amount, yeah? So part A, show that the number of mosquitoes is increasing at time 6. How do I know that the number is increasing? So the number of mosquitoes is increasing if the rate is positive. So don't I just need to find the rate at time 6? Okay, so I need to find R of 6, which is 5 square roots of 6 cosine of 6 over 5. Now this is a calculator question, so I would type that in. 5 square roots of... 5 square roots of 6. Oh my good lord. I cannot type this in. 5 square roots of 6 times the cosine of 6/5. And you get a positive number, right? So, what do you say? How do you justify? I would say the number of mosquitoes is increasing at time equals 6 because why? Why did we just do that? Because R of 6 is positive. Okay. What about B? At time equals 6, is the number of mosquitoes increasing at an increasing rate, or is the number of mosquitoes increasing at a decreasing rate? So we already know the number of mosquitoes is increasing, right? How do I know if it's increasing at an increasing rate? Well, I know that R, so we got the number, which is F, we got R, which is F prime, and then F double prime is R prime, right? Does that make sense? So I know that this is increasing. We already know that this is increasing, right? F, which is the number. I know that R is increasing when R double prime is also positive. I know R is decreasing when R double prime, or R prime is negative, which is F double prime. Does that make sense? So maybe we take the derivative again and plug in 6. So I'm going to find R prime at 6 in my calculator. Now, I'm assuming that we would have typed this in our calculator, right? In y1. So, 5 square roots of x, cosine of x divided by 5. Second quit, alpha, window, number what? Don't I want to find the derivative of y1 at x equals what? 6. And I get what? Okay, I get a negative number. Negative 1.91319. So, because r prime is negative, r is decreasing. Therefore, oops, I was just writing that really weird, wasn't I? The number of mosquitoes is increasing at a decreasing rate. It's kind of interesting. According to the model, how many mosquitoes will be on the island at time 31? Round your answer to the nearest whole number. Okay, so how do you figure out how many mosquitoes will be on the island? The antiderivative of the rate from 0 to 31, right? What do I do with that? Good. Initial plus change in the number of mosquitoes equals final. So the number of mosquitoes at time equals 31. We're good, right? Okay. D, to the nearest whole number, what is the maximum number of mosquitoes from time 0 to 31? Show the analysis that leads to your conclusion. So we're trying to find a maximum number, right? The maximum number is what? First we need to find what? If you're trying to find an extrema, a max or a min, on a closed interval. What do I put in my t-chart? Zero, 31, and critical points. How do I find critical points? Okay, you set the derivative equal to 0. So when 5 square roots of t cosine of t over 5 equals 0, right? So you write that down. You go ahead and just graph it from 0 to 31. So window 0 to 31. I'm going to go negative 6 to 6. Oh, crap. Yeah, I changed my scale. Negative 6 to 6. Graph. I see 1 critical point. I see 2 critical points. Okay? Yeah? So second calc, 0. If this is 31, 1, 2, 3, 4, 5. I'm going to go with 7. And then I'm going to go with 12. Okay, so one of them is 7.8539816. So I can calculate 0, 20, 27, and I get 23.561945. Now, these are crossing here and here, right? So if I let this be A and this be B, which one can I discard as a maximum? Why? Why can't I discard the B? R changed from negative to positive, meaning R, the antiderivative R, the number had a minimum. Okay, so I need to consider 0, A, and 31, right? Do I know how many mosquitoes I had at time 0? 1,000, right? And I figured out how many at 31, right? Answer from part C. So 1,000 plus the integral from 0 to 31 of R. Isn't that the same way I find this one? 1000 plus the integral from 0 to a of r. Whichever one's your bigger is your maximum. What theorem is this that proves you have the maximum on a closed interval? Remember we're talking about extreme value theorem, right? How do I know that extreme value theorem works? Continuous and differentiable? And I mean that is the derivative. So the derivative does exist, right? Okay, and if the derivative exists, then it is continuous. Okay. We're gonna skip that one. I'm not gonna stop the video. Let's just go ahead and do integral defined functions, yeah? Okay. So, didn't we already do this one? The first one? It was E. Okay. What about 2? Can you do that one real quick? So if you're taking the derivative of an integral from 0 to x cubed, what do you do with, what do you do? X to the what? 6. And then you multiply by what? Okay, so E. And we already did 3, so don't worry about it. The graph of the function f is shown in the figure to the right as horizontal, and the graph of the function f shown in the figure has horizontal tangents x equals 3 and 6. If g equals the integral from 0 to 2x of f, what is the value of g prime of 3? So how do I find if g of x equals the integral from 0 to 2x of f of t dt? What's g prime? Times? Okay, so what's g prime at 3? F at f at 6 times 2, right? Because we're plugging in x equals 3. So what is f of 6? Go to your graph. -1? Okay. Okay. G of x equals the integral from a to x of f of t dt. For what value of x does g have a maximum? A. Think about area, right? You can either think about this as area or you can think of it as a derivative. One way to think of it is g is the integral, right? So if I do the integral from a to b, is that a positive number? If I do the integral from a to c, is it a bigger positive number? If I do the integral from a to d, what happens? You take away some area, right? So I'm thinking c. Now another way to prove that is if g equals this integral, then what's g prime? Just f of x, right? So if this is g prime, then when does g have a max? Well, when g prime changes from positive to negative. Yeah? Okay. G is the integral from 0 to x of sine of t squared dt from -1 to 3. On which of the following intervals is g decreasing? How do I know when g is decreasing? G is decreasing? When g prime is negative. So what's g prime? Okay, so how would I know when sine of x squared is negative? Profit? From what to what? Okay, and then I just look and I see when it's negative and then I pick my answer, right? Okay, move on. G of x equals the integral from a to x of f of t dt, where x is between a and b. The figure above shows the graph of g on AB. Which of the following could be the graph of f on AB? Okay, so g equals the integral of f. What does that mean about g prime? It is f. And aren't we looking at g? So when it says which one could be the graph of f, they're really saying which one could be the graph of g prime, the derivative of this. So if g is increasing, what does that mean about g prime? No, you're right. G is increasing, so g prime should be. And then g is decreasing, so g prime should be. So which one has a positive and then a negative between a and b? C? Yeah, positive and then negative, so yeah, C. Okay? F of x equals the integral from a to h, or a to x of h, where h is the graph shown above. So this is the graph of h. Which of the following could be the graph of f? So make sure you go ahead and tell me what this relationship is. What is it? Every time I do this, every time I see this function equals the integral of that function, what do I do to both of them? Exactly, take the derivative. F prime is h. So when it says which one could be the graph of f, realize that we're looking at f prime. Right? Does that make sense? So f prime is what here? Is it above or below the x-axis? Because I've got two different charts to pull from. I know that when f is increasing and decreasing, f prime is positive and negative. So therefore, if f is positive and negative, then f is increasing and decreasing, right? I also know that if f prime is increasing and then decreasing, that means f is concave up and concave down. So I could say concave up, concave down, concave up, concave up, concave down, concave up. But I could also say f prime is positive, which means what? Increasing, and then f prime is negative, which means f is decreasing. So which one? I'm thinking E, right? Concave up, and then concave down, and then concave up, and then increasing and then decreasing. Okay. Basically, we should have been looking for a max at B, and then it couldn't be A because of the... Okay, there you go. You're just smarter than me, okay?
No, I'm not.
Okay, fine. Jeez. Okay. Haven't we already done this one in class? This one right here?
Yeah.
Okay, so we can... Have we?
No.
No, it's 1997. Yeah, we did one similar, but we didn't do that one. These are too old. I haven't done these. Okay, so we'll do similar. You were born when? 97? You old fart. Okay. I was born in 86. The graph of the function f above. Chris, were you born in like what, 72? Okay. The graph of the function f consists of 3 line segments. Let g be the function given by g of x equals this integral. Yeah? So right off the bat, if g equals this integral from -4 to x of f of t, one thing that I'm going to go ahead and write down is what? What can I do to that relationship? So g prime equals f of x. So I'm going to go ahead and write down that I know that on the graph, I'm actually looking at f, which is the same thing as saying g prime. Okay, so for A, it says find g of -1. So I've got to go back to the original equation, right? The original equation is g of x equals the integral from -4 to x. So -4 to -1. Yeah? So what does that mean I need to do? Sure. So I need to find the area from here to here. Yeah? What's the area formula for that trapezoid? Or you can do rectangle and triangle, I don't care. 1/2 base is, what's the height one? -3 and height 2? Negative 2. So I've got negative 15 halves. Yeah? Okay, which I could just leave it like that. Whatever. Alright, what about g prime at negative 1? Okay, so negative 2, because we're looking at the graph of g prime. What about g double prime at negative 1? What's g double prime? It's the slope? So what's the slope of the graph that we're looking at negative 1? What's the slope right here? Isn't that a corner? Yeah? Slope doesn't exist. Okay. For the function g defined in part A, find the x-coordinate of each POI on the graph of g on the open interval. Okay, so I'm going to go ahead and do my little chart. G has a point of inflection right there and there, right? So when g prime changes from increasing, decreasing to increasing, or from g double prime changing positive to negative to positive, or vice versa, right? Okay, so what graph are we looking at? Okay, and you need to state that. Anytime you're going to use that, state it. F is g prime. Therefore, because f changes from increasing to decreasing, where? At x equals what? At x equals 1, g has a POI at x equals 1. Does that make sense? Okay. Alright, let h be the function given by the integral from x to 3 of f of t. Find all values of x on the closed interval for which h equals 0. Okay, so tell me about this relationship. What are you going to do? Be careful, though. What's different? So h prime equals what? Negative f of x? Okay. So what does a negative f mean? What does it do to the function? It just flips it, right? So now it looks like this. And then it does this number. Yeah? So I got that going on. Okay, when does h equal 0? Interesting. Okay, I could work this two different ways. We're looking at the graph of h prime, right? Okay. Might be easier to go ahead and think of it like that. If I take the integral from what to 3, when does it equal 0? Well, couldn't I think about it as area? So if I go all the way to 3, what would cancel out with this area? At 1? Okay, so x equals 1. What about if I went another, then if I did this? Would they all cancel out? So the other one is negative 1? Okay. So I started to go that route, but then it makes it easier just to go ahead and think about areas. Okay, interesting. For the function h defined in part C, find all intervals on which h is decreasing. So that is when we use this h prime equals negative f of x, right? So h is decreasing when h prime is what? Negative. So when is h prime negative? And we're looking at we flipped it over, right? So when is the graph of h prime negative? 0 to 2? Okay. Well, there you go. Wasn't that fun? They all agree. That I did that problem? Oh, be quiet. Hey, everything we do is making other people do too. We'll skip the middle one and go with this one, okay? Okay. Let me see real quick. Okay, let's go ahead and start doing it. How do you find G of 3? Okay, how do you get the area from 0 to 3? Okay, so pi over 4 times the radius squared. So 1/2, what's the base? What's the height? I'm going to go with -1. Right. So you can either say minus the area of the triangle or just go ahead and say plus the area of the triangle with the height being -1. Either way. So there we go. That's G of 3. Find all values of x on the open interval from -2 to 5 at which G has a relative max. When does G have a max? Well, what are we looking at? Good. So we're going to write that down in our answer for part B, right? G prime is F, therefore G has a relative max when G prime, which is F, changes from positive to negative, therefore at x equals what? 2. Okay, good. Write an equation for the line tangent to the graph of G at x equals 3. So what goes in the x value? 3. What goes in the y value? G? Didn't we already do that? It was pi minus 1/2, right? So I'm going to write pi minus 1/2 in parentheses right there, yeah? Okay, and then now what? Oh, we need to find the derivative of G at 3? Look right there. Oh, I thought you said, oh, you were saying find the slope. And so I thought you were going to try to start finding slope at a point.
No, it's just the point at the, it's just the,
My bad. I don't trust you.
Sometimes I do it.
That's okay. So what would you say? Yep. And there we go, right? Find the x-coordinate of each point of inflection of the graph of G on the open interval. Justify your answer. So when does G have a POI? When G prime changes from what to what? Or vice versa, right? So at x equals what? 0 and 3? Okay.